Well, welcome back to our third lesson in Chapter 6. In this lesson, we're going to prove that quadrilaterals are parallelograms using a variety of different theorems. And a lot of these are going to be converses of the theorems we've already used. So in our last lesson, we learned some properties about parallelograms. And in this one, we're going to take some of those properties and use the opposite of those or the converse of those properties to prove that quadrilaterals are parallelograms. So our first theorem, Theorem 6.8, says that if you have both pairs of opposite sides in a quadrilateral being congruent, then that's enough information to prove that it is a parallelogram. So as long as the opposite sides, both sets of opposite sides are congruent, then it's a parallelogram. Two more theorems for you. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it's a parallelogram. So for instance, if we have the angle A down here, and A plus B is 180, but A plus D is also 180, then that's enough to say it's a parallelogram. As long as the consecutive angles, the ones that it's next to, it has to be both pairs of consecutive angles must be supplementary. Theorem 6.10 tells you that if you have both pairs of opposite angles in a quadrilateral being congruent, then you also have a parallelogram. And so let's go ahead and try a problem with some of those three theorems. It says, for what value of y must quadrilateral PQRS be a parallelogram? So what values of y? We want to know what y is equal to. And in order to find y, in this instance, we're going to have to find x first. So let's go ahead and start out. We're going to set opposite sides being equal to each other. So we'll start with 3x minus 5 on the top, side PQ being congruent to SR. And we can go ahead and solve this for x. If we subtract 2x from both sides, we get x minus 5 is equal to 1, or x equals 6. So there we have what x is equal to. So now we should be able to figure out what y is equal to. And we can do that by setting the opposite two sides being equal, QR and PS. So y is equal to x plus 2. And substituting in the 6 right there for the x, we get 6 plus 2 is equal to 8. So in order for PQRS to be a parallelogram, y has to be 8. Here's another one for you to try. Go ahead and pause the video, and when you turn it back on, I will give you your solutions. All right, hope you had a chance to give that a try on your own. In this scenario, we have 4 different algebraic expressions for the angles of the quadrilateral. So one of our theorems said if the opposite sets of angles, both sets of opposite angles are congruent, then they're congruent. So our first equation that we could set up would be 3y minus 2 plus 4x plus 13 is equal to 180. Actually, I used the other theorem. I used the theorem that said that the two sets of consecutive angles are congruent. So if I set this one plus this one equal to 180, then I could also say that 3y minus 2 plus the one below it, angle E and angle H, are supplementary. So as long as E and F add to 180 and E and H add to 180, then we should be okay. Well, here is the math behind this one. If we combine the like terms, we get 4x plus 3y equals 169. And on the right-hand side, combining those, we can actually solve it for y, and we get y equals 43. Well, the next thing we can do is take y equal 43 and plug it into the left-hand side equation, and that will give us x equal 10. So in order for this to be a parallelogram, we must have x equal to 10 and y equal to 43. A couple more theorems for you. The first theorem, 6.11, says if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So if you have two diagonals, and each of those diagonals gives you congruent segments in the diagonals, then it's a parallelogram. And theorem 6.12 says if you just have an opposite pair, opposite sides being both parallel and congruent, then it's a parallelogram. So here's one that says, can you prove that the quadrilateral is a parallelogram based on the given information? So in this problem, we're given that side AB and CD are congruent and their lengths are 5. Angle A is 50 and angle D is 130. We want to prove that it is a parallelogram. Is that enough information? Well, we have one pair of sides being congruent, and we have one pair of angles being supplementary, and it turns out that is enough information because we have same side interior angles being supplementary, which tells us that A and D are supplementary, so we know that AB and CD are parallel. Since we have same side interior angles being supplementary, that's the converse of the same side interior angles theorem. So we do have a parallelogram by Theorem 612. How about on the right-hand side? HI is congruent to HK, and JI is congruent to JK. Do we have a parallelogram? Can we prove that that's a parallelogram? And this one is a no, because we need to have the opposite sides being congruent, not the consecutive sides. All right, so this is a really good summary of the different theorems that you've been given and pictures that show you what they mean. So this will be a good resource for you when you get to test time. So I'm not going to say much about this, just a summary of all of those theorems on one page. Here is your lesson check, problems 1 through 3. Go ahead and work on this and bring your answers to class. See you next time.